Okay, in the previous video, I had promised to redo this thing using Green's theorem. Going to use Green's theorem to find the integral of xy dx plus 2x minus y dy, which is the equation of each vector in a vector field. We're going along from 0 to 1, we're going along y equal x squared, and then back down to along y equal the square root of x. Alright, so the formula for Green's theorem you have here is the integral of p dx plus q dy is the double integral of dq by dx minus delta p by dx minus delta p by delta y. Now here we are going to do our double integration. Let's erase the previous work. So what we have in integrating this is going to be a double integral. You can go dx first and then dy. What we're integrating is delta q by delta x minus delta p by delta y. We see that p, comparing, p is equal to xy. So since p equals xy, then delta p by delta y, delta p by delta y is equal to x. And then we see here that q is 2x minus y. So since q is equal to 2x minus y, then delta q by delta x is equal to 2. So with Green's theorem, you differentiate the vertical component with respect to the horizontal axis, and the horizontal component with respect to the vertical axis. So here now we have delta q by delta x being equal to 2. Alright? Delta q by delta x is 2. So delta q by delta x minus delta p by delta y is going to be 2 minus x. So you're integrating 2 minus x. Alright? And here you're going from this curve on the left. If you go dx, changing x, this curve on the left out to the right, what you're going to have is going to be from x equal y squared to x equal y to the half. So from y squared to y to the half, and then along y now you go up from 0 to 1. So you go from 0 to 1. So here you have 2 x minus x squared over 2, and you're going from y squared to y to the half, and later on you're going to do the next integration from 0 to 1 dy. Then substitute 2 y to the half minus y to the half squared over 2. You minus that's the upper boundary minus the lower boundary now. It's going to be 2 y squared minus y squared because y squared would be x, and that is squared, so it's y squared squared over 2, and then we will later on differentiate it with respect to y. So we put it there so that we don't forget that it should be done, right? It keeps reminding us that that second integration should be done. So you have the integral from 0 to 1 of 2 y to the half minus y to the half squared is just y over 2 minus 2y squared minus and minus give you a plus. Y squared squared is y to the 4th over 2 dy. When you differentiate this with respect to y, you get 2 y to the half plus 1 is going to be 1.5, which is 3 halves over 3 halves minus y squared over 2 2's 4 minus 2 y to the 3 over 3 plus y to the 5th over 2 5 10, and you're going from 0 to 1. When you put 1, you're going to get, let's erase the previous work, get it out of the way. When you put 1 there for the upper boundary, you get 2 over 3, right? So you're going to get 2 over, oh, this should have been cancelled, but anyway, minus a quarter, right? Why I write 2 here? It's not over 12. Where I get this one from? 3 halves over 3 half. Oh, it's not 12. It kind of look like 12. This little mark here shouldn't be there. Let's get rid of them. Make it look like 12. Minus 2/3 plus 1/10 equal. So fractions now. We deal with the fraction 2 over 3 over 2 is 2 2's 4/3 minus a quarter minus 2/3 plus 1/10. And you work out the fraction. So I'm going to use a fraction calculator off the screen. Well, I don't have any fraction calculator installed. But 4 over 3 minus a quarter minus 2/3 plus 1/10 equal 31 over 60. Same answer that we had got before. 31 over 60. Alright? So that's Green's theorem. Remember, with Green's theorem, you have to remember the your double integration. Hopefully when you get exam, they give you Green's theorem, Green's theorem's formula in a formula sheet. But suppose you don't, well, it's not so easy to remember this formula, you know. But remember the double integral part, you differentiate the horizontal component with respect to the vertical and minus the vertical component with respect to the horizontal. That's one thing you could remember, right? It's p dx plus q dy. Alright, so I'll see you in the next video then.